Hello friends, so today in this particular session that we are going to learn how to prepare the MATLAB code for the false position method and Newton's-Raphson method. Okay, so first of all we will go through that particular false position method and then how to run that particular codes and programs that we will see in the next session. So in the last particular session that we have seen that how to particularly use that particular different windows in the MATLAB. So basically when we want to prepare the programming in the MATLAB as an for the permanent part, so we have to use this particular editor window, and this particular command window here we can be able to put that different kind of that functions, and then we can be able to run the different particular programmings. So related to that particular false position method that we knows that whenever we want to use that particular section bisection kind of that method, that in the last particular video we have seen how to solve that particular problem root of equations by using the bisection method. Now in the similar manner, first this particular programming is divided into the two parts. One, that is which kind of that gradients which is required. So that particular part we are knowing as an here just I will put something as in terms of percentage which is not impacting much. So this is the false position method. So we are just today going to see the programming on this particular false position method. Okay, so just I have written that in terms of percentage, so that will not be create any kind of that impact on that particular programming, just to see that particular what kind of that part it is there. So this particular just I have written as a false position method. So first we are going to be give some sort of that ingredients. So this particular ingredients is nothing but the some sort of that input. So basically that we knows that what is this particular formula for this particular false position method. So this is the basically that particular formula is there for this false position method. So just I will put this particular formula in this command window, so that particular formula will not be much impacted. So what is that, when we want to go for that next root, that is x2, so we have to see that particular two things, that is the first root and second root. Here this particular two roots we have to provide as an input, and then we have to provide the function as an input. So here just I will write f, that is input, that here we have to write, or where when we want to prepare that user friendly program. So this is the enter your input, so this is the enter your function, so this is the input command. So user can be able to understand that here we have to put whatever may be this particular function. So just if you want to see this particular part into the command window, then don't give any semicolon, but if you want to hide this particular part, just use the semicolon. Okay, so then what we are required as an input, that two things, that is the x0 and x1. So what is this x0? So x0, this is the first root, that is we can be able to say x0, that is the input, this is the enter the left side root, initial root, and next one x1, that is as an input enter the right side root. Okay, left side and right side root. So these are the some basic ingredients required. Now apart from this, what is it we are required? We are required here how many part of this so here we can be able to see that is the number of iterations. Okay, so this particular part here we have to use this as an input as a number of iterations. So how much iteration you are expected that you have to use, or ask the user, that is enter the number of iterations. So here user can be able to give the number of iterations for this particular program. Okay, so this is the number of iterations, and then what we are expecting, that is if we are required to give the tolerance, that we have to give, or else it is not required. So then next is the processing, how this particular process that has been carried out. So here basically that we first have to be give the conditions. So what is that particular condition that we need to be analyzed? So that first condition that we knows, what is that first condition, that f of x1 into f of x naught into f of x1, this should be less than 0. So what it means, that one of the function should be positive and one of the function that should be negative. This is the first condition. Means whenever we are putting that x naught and x1, so for any value of that x naught or x1, your function should be positive, as well as for the next value that function should be negative. This is the main condition. And second condition, that this particular f of x naught and f minus f of x1 minus x naught, that should not be 0. If it will be 0, then it will be gets invalid function. Okay, so that particular part I will put over here, f of x1 minus f of x naught, it should be not equal to 0. So these two conditions are important while running this particular program. These particular two conditions, that is important, and then we will end this if loop. Now in between, in this particular if loop, we have to generate the for loop. So for, I am just using the variable I, that is equal to, it will be start from 1 is to n. What it means? So it will be start from the first iteration and it will be end at the last iteration. So how much user is going to be give as an iteration, that will be, we are using it, and then we will end this particular for loop. And in between that, what we have to write? We have to write this particular program, means whatever may be this particular equation which is required. So just I will use this particular equation over here. So this particular x2 minus x1, and then we have to run this particular conditions. So when we are running this, we need to be checked, means what we have to do, like a bisection method, we have to replace our one of the roots with the different conditions. So what is that particular condition that we have to write? Okay, so if we have to check f of x naught or x1 into f of x naught, if it is less than 0. Okay, there are the two conditions once again. Either whenever we are just putting as an x1 and x naught, okay, so like this particular part here, we need to be check whether f of x1 or x2, whenever it will be get 0, what we need to be replace, whatever maybe the replacement is there, that what we have to replace, x naught, that should be equal to, it should be a capital one, x naught, that we have to replace with this x2, that is as a new one. Why? Because here if f of x1 if it is 0, then means f of x2 if it is positive, then this will be a less than 0, that is only possibility. So we need to be replace x naught by the x2. Then what we have to do, once again we have to check the second condition, that is by again if we are replacing this particular part, okay, so we have to use the second condition, that is as an else if. So else if f of second condition, what is that condition? Second condition, that is f of x naught into f of x2 if it is less than 0. So this is the second possibility what we will achieve. Okay, so f of x naught into f of x2 if it is less than 0, then what we have to do, we have to replace this x1 by the x2, means old one by the new one, and then here we need to be in the program. So once you are going to be an end here, if this particular condition, if it is not possible, means if it is not valid, then what exactly we have to do? What we have to do? That is, we have to use, if this condition is not possible or if it is not obtaining, then else here you can be able to use display invalid roots. And then you have to in this particular program. So this is all about the false position method. So this particular program, how to run this particular program, that particular part we have to see in the next lecture. So while saving this particular program, you have to go save this particular program. So if you have just created the different registry for this, just I have created for the MATLAB. So just I will open this particular part of the MATLAB, and here I am going to then save this particular part as a false position method FPM, and then I am just going to save this. So here you can be able to just go and check once. So just save this and then run this particular part, add to the path, and in the command window here you can be able to see the function. So here you have to enter the required function and then just check whether your program is executed or not. So thank you very much.